Good morning. Today we're going to be talking about Graham's Law of Effusion. So Graham's Law states that the rate of effusion for a gas is inversely, that word is really important, proportional to the square root of its molar mass. So when we're using this word inversely, remember that means that we're dividing. So we have 1 over its molar mass. So I'm using hypothetical gas A. So we have the rate of effusion for gas A. Remember, it's inverse, so we're using 1 over the molar mass of gas A. So if you remember from your research, effusion is the rate of a gas moving through a teeny tiny hole. So we're trying to find out how fast a gas can move through that teeny tiny hole. Kind of a gas moving, if you put a teeny tiny hole into a balloon, how fast is that gas going to be able to escape from a teeny tiny hole in a balloon? All right, a lot of times we're not actually calculating the rate of effusion of one gas. We actually want to compare gases. So we might talk about the rate or compare rates of gas A to the rate of gas B. Since we have the rate of gas A on the top, we're going to keep the molar mass of gas A on the bottom. Again, because it's inverse. And since the rate of B is on the bottom, it's going to go on the top. So this would give you a ratio of the rates of rate A to rate B. Oops. Alright, so if I'm trying to find the ratio of gas A to gas B, I would find the square root of molar mass of gas B to the square root of molar mass of gas A. So now we're going to do a couple practice problems and see if we can figure this out. Alright, first question we have is to calculate the ratio of effusion rates for helium to oxygen. So I'm going to rearrange my equation so that I don't have gas A and gas B. Now I'm going to have helium and oxygen. I'm going to put helium first because it wants the ratio of helium to oxygen. And I'm going to have the rate of O2. Oxygen by itself is a diatomic, as we've learned. So, and with oxygen in our air right now, it is O2, not just O. So we're going to write the rate of O2. And remembering from our equation, helium, since it's an inverse, is going to go on the bottom. I always write that one first. So I'm going to have the molar mass of helium and my molar mass of oxygen on the top. And then I can continue my rate of helium to my rate of oxygen. Now I can plug in with their molar masses. The rate of O2, if you need to come over on the side, okay, remember to find the molar mass. We're going to say I have oxygen, I have 2 of them multiplied by the molar mass of oxygen, which we can find on the periodic table is 16. 2 times 16 is 32 grams per mole. So I can put that on the top, 32.00 grams per mole. Divided by the molar mass of helium is also on our periodic table, 4.003 grams per mole. The square roots of the grams per mole are going to cancel. You can plug that straight into your calculator. Or if you could take the square root of 32 and the square root of 4.003. I'll do that since this is our first problem. So I'm going to do the square root of 32 is 5.65. And the square root of 4.003 is 2.007. I'm going to say that rounds to 2.00. And then I can divide, I'm going to put this over here, the rate of helium to the rate of oxygen. Remember, we're doing a ratio of rates. So when I divide this out, I get 5.65 divided by 2.00, and I get 2.83. Now, since it is a ratio of rates, I'm going to put that over 1. Why am I putting it over 1? What this actually means is, remember that effusion is a gas going through a tiny hole. So what that means is, I'm going to have 2.83 helium atoms going through a tiny hole for every 1 oxygen molecule that's able to go through that tiny hole. All right, moving on to our next problem. This problem says to calculate the molar mass of ethane. Ethane's rate of diffusion is 3.6 times slower than hydrogen. Alright, so our next problem says to calculate the molar mass of ethane, where ethane's rate of diffusion is 3.86 times slower than hydrogen. So this problem is a little bit different. We're not calculating our rate of diffusion, we're given our rate of diffusion, and we're also given both of our gases. Alright, so we can recall that we're given a rate of one gas over a rate of another. Okay? So we have to decide which one is going to go on the top and which one is going to go on the bottom. So the way the question is worded, it says ethane's rate of diffusion is 3.86 times slower. That word is extremely important. What that tells me is that hydrogen is going to get through that teeny tiny hole 3.86 times more than ethane. So I'm going to put hydrogen on top. And I'm going to put ethane on the bottom. That's going to help me set up this next formula. Alright, so I'm going to have the square root of the molar mass, which is what I'm solving for, of ethane. Remember that whatever's on the bottom over here goes on the top up here. And the square root of the molar mass of hydrogen. Remember, hydrogen is a diatomic. That's why I'm putting it as H2. All right. Now, the problem gives me this quantity. It gives me the ratio of rates. It tells me that I know 3.86 over here. I can also figure out the molar mass of hydrogen. So I need to figure out the molar mass of ethane. And go over, I can go over onto the side. again, I have hydrogen, 2 of them, times 1.008 is equal to 2.016 grams per mole. So I'm going to have the square root of 2.016. And I'm going to go ahead and find that square root to make my math a little bit more simple. So the square root of 2.016 is 1.41. So I have the square root of the molar mass ethane over 1.41. In order to get rid of my 1.41, I need to multiply that on both sides. Remember, whatever I do on one side of my equation, I have to do to the other side. So I'm multiplying both sides by 1.41. All right. Now I'm going to erase this so I have a little bit more room. All right. When I multiply my 1.41 by 3.86, and actually I just looked at my calculator, that should be 1.42 when I round. So it was 1.419. So I'm going to get 1.42 multiplied by 3.86. And I get 5.48 is equal to the square root of the molar mass of ethane. So how do I get rid of the square root? Well, I need to square it. And again, whatever I do to one side, I do to the other. So I'm going to square my 5.48. Now I get 30.04 is equal to molar mass of ethane. And you are done.